And like I wrote last week on my blog, here's a video presentation of my latest project, robot mapping and exploration using WebSockets and HTML5. I'll start with a description of the hardware, and namely the robot. We have a Pololo base, some infrared obstacle detectors, an RFID card reader. We have Maxbotics sonar here that I got from SparkFun. There's an infrared emitter and a receiver that I also got from SparkFun. We have a compass module that I got from SparkFun. A servo here that I ended up not using. It works, but it's not used in the latest incarnation of this project due to the complexity of calculations that come with orientation issues, because the body of the robot moves and also this has an ankle. So for now we are not using the servo. Then the wheels, the motors, the octal encoders are all from Pololo, and that's why they mount so well to the Pololo base. At the back here we have a rechargeable battery bank that provides 7.2 volts to the robot. I'm using two Arduinos. The reason for that is because I have a considerable amount of devices, the servo, the sensors, and I was having trouble getting enough inputs from only one board, and I had another one laying around, so I decided to use that. And the way that I've organized them is the bottom one is the main communications board that, as you can see, connects to XB Shield from SparkFun. The top one connects to all the inputs and also provides some outputs that make namely make the robot move, because the outputs are the motors. There's some conditioning electronics that I had to put in here. And in terms of hardware, that's pretty much it. Now, information from all these sensors is sent wirelessly through the XP module to the XP receiver that is connected to the computer. This is my computer that is currently running quite a lot of things. It's running a simple web server. This is the debug window for the web server. This is the debug window for the WebSockets server, and as you can see now, I have kind of a heartbeat monitor going on, confirming that communications between the robot, the server, and the connection to the client that we're going to see later all are working in a good way. Then we have the client window, which basically is a Safari web browser running on Windows. The reason for that is because Safari at the moment is the only, or not at the moment, but is currently the only browser that supports the version of WebSockets I'm using, which is Draft 76. There is actually a new version out, but this Safari doesn't support it, and my code is only for Draft 76, and I don't want to rewrite all the code for the latest version. Okay, for the interface, basically all the values are being updated in real time. This is sonar information. As you can see, that's the complex orientation, left speed, it stops, so obviously it doesn't show anything. It's got the servo position and the optical direction, which is taken from the optical detectors, obviously. Okay, just as a demo, I am going to rotate the robot, and you'll see the compass, the heading number changing. There are some, there you go. We're rotating the robot. Okay, and we're going around, and this is going around, so the compass will, depending on orientation, give me a number between 0 and 3600, and it will be updated real time in the client connection. This is the common browser, and the connection is through WebSockets. What I'm going to do now is I have demonstrated the possibility of receiving and displaying data real time using WebSockets. I am going through these buttons here at the top. I am able to send information out using WebSockets that can manually move the motors in a forward, reverse, rotate the robot clockwise or counterclockwise. So if we press the forward button, it moves forward if we let go of the button. If we press the reverse button, they move reverse. If we press the clockwise rotation, both motors will rotate in a different direction. This is just a demo of what I have achieved so far. An extra thing, which is the use of HDMI5 canvas element, is on this empty